Hello and welcome. In this video, we're going to be starting the series of how to sketch any function. And for this series, I've prepared a number of steps that if you follow, you will be able to successfully sketch any function. So let's go together through the steps. First thing is that we need to determine the domain of the function, and I'm going to tell you what is the domain in this video, as well as locating the x and y intercepts. And these first two steps are going to be the objective of today's video. We're going to have a series of videos where I go through all of these steps and how to do them successfully. And then I'm going to do videos on combining everything to sketch super difficult functions so you can follow along. So the third step is to determine something called the vertical asymptotes and holes or cusps. Fourth is to determine the end behavior and horizontal/oblique asymptotes. Fifth one is to calculate the first derivatives to get the critical points and to determine the intervals where the function is increasing and decreasing. The sixth and last step is to calculate the second derivative to determine the concavity of the function. When is it concave down and when is it concave up? And you can use this information to find something called the inflection points. I know this could be overwhelming. However, I'm going to design the series in a way that it's very coordinated, very well designed for you to carry out questions like these. So in today's videos, we're going to take a look at getting the domain, y-intercept and x-intercept of a function. So first of all, let's start by saying what is the domain. Domain of a function is basically all the values that the function can take in x. What does that mean? Let's say if I have a straight line like this, do I have any restrictions for my x values? And can x be -3? Yes, I will have a successful y value. Can x be 1000? Yes, I will have a y value. Can x be 0? Yes, and so on. So for this straight line, x can literally be any single value from -infinity to infinity. So this is my domain, is from -infinity to infinity, and this is how you write your domain. Is this true for all functions? No, because some functions will have some restrictions. Like what? Let's start by saying we'll take a look at the function y equals square root of x. First of all, there is a restriction here. We can watch it graphically or we can analyze it algebraically. Let me tell you both ways. So first of all, do we know that we cannot square root any negative number, right? So my restriction here is that my x should be greater than or equal to 0. The least value of x that x can successfully have is going to be 0. Anything lower than that is going to be negative, and this whole thing is going to be undefined. So my domain over here, my domain is basically x greater than or equal 0, or my domain is x from 0 up to positive infinity. And if I would graph this function looks something like this. The square root function looks something like this. And I can see that for any positive value of x, I will have a successful value of y. However, if I take x as -1, for example, I do not have any y value. That means that the function is unidentified. So basically, this is our goal for today. Y-intercept is where the function crosses the y-axis, and x-intercept is where the function crosses the x-axis. Okay, so let's put on some ground rules that will help us in solving. First of all, if I have any polynomial function, which is a function that looks like this, let's say it's x plus 1, or x squared plus 3 minus 4, or x cubed plus 5 minus 5, so minus 5x minus 5, let's say, or x power 4 plus x cubed plus 3x squared minus 2. So these are all examples of polynomial functions. They're literally some degrees of x. We have some higher degree of x, and then other terms including x or including constants, okay? However, we do not have any x's in the denominators. This is no longer going to be a polynomial function. So let's agree that the domain, I will just write it d from now on, domain for any polynomial function is basically all real numbers, which means that the domain is from -infinity to infinity, because I do not have any restriction for my x. My x can be anything, literally. If I have a square root function, let's say square root of x or square root of x minus 4, for example, my restriction is that the term that is under the square root should be greater than or equal 0. So the domain for this function is going to be x greater than or equal 0. The domain for this function is going to be x minus 4 greater than or equal to 0. So x is greater than or equal to 4. And this could be written as x is from 4 up to infinity. Okay. Third thing that we're going to look at is basically when we have a rational function. Rational functions are functions where we have an x in the denominator, an x term in the denominator. Let's say an example is the function y equals 1 over x, for example. What is the restriction here? I know that I cannot divide anything by 0. So if my x is 0, this is going to be undefined. So this will not work. So in rational functions, the denominator cannot be 0. This is my restriction. So if I have a rational function like this, x plus 5, then I would say x plus 5 cannot be equal to 0. That makes x not being able to equal -5. I will move the 5 over there, because if x is -5 plus 5, it will make my function or my value 0, which will make my function undefined. So my restriction here is that x is not equal to -5. How would I write that in domain form? It's going to be x is going to take values from -infinity up to 5, and if I have my bracket a parentheses like this, it means that I'm not including the 5. However, if I have a square bracket, it means that it's up to and including 5. So here the correct thing to say is from -infinity up to 5, but not including 5. Okay, union with from 5 to infinity. This is how I write my domain. So with that all said, let's take some examples and try to solve them and see if our solutions is correct by viewing their graphs. So the first example that I have is y equals x squared minus 4x plus 3. Okay, straight away, this is a polynomial function of a degree 2, so it's a quadratic. Since it's a polynomial, my domain is going to be all real numbers, so from -infinity up to infinity. This is my domain. What I want to find next is my y-intercept. So what is my y-intercept? To find my y-intercept, I will set my x equals 0. So over here, this is going to be 0 squared minus 4 times 0 plus 3. Y equals this. So this is 0, this is 0, so y equals 3. So my y-intercept is going to be at y equals 3, and it's going to be a point of 0 and 3. This is my y-intercept. To find the x-intercept, we basically do the opposite. We set y to 0. So over here, instead of y, it's going to be 0 equals x squared minus 4x plus 3. And this is a quadratic. And by the way, I have a full playlist on how to deal with quadratics. Check it out on the top right-hand corner. To solve this, I can use factorization. I know the factors, since this is plus, I will need two factors of 3 that add up to 4. They're 3 and 1. So I'm going to have x, 3, and 1. Since this is a plus, they will both take the middle sign, which is minus, so it's minus, minus. So this is 0 equal. So over here, I will have two solutions, either when this is equal to 0 or when this is equal to 0. So x minus 3 equal 0. That makes my x equals 3. That's my first solution. And x minus 1 equals 0. That makes my solution x equals 1. So my x-intercepts are at points 3 and 0 and 1 and 0. Let's check if our solution is correct. So let's try to plot this function and watch. So what we calculated is domain is all real numbers. Yes, it can be any single value. And our y-intercept, we calculated it as 0 and 3. 0 and 3, that is our y-intercept. Our x-intercepts were 1 and 0, 3 and 0, and this is the correct answers. So let's take another example. Let's say we have a function y equals 1 over x plus 5. So this is a rational function. I know that the denominator cannot be 0. So to find the domain, I will need to say that x plus 5 cannot equal 0. So let me solve for x. Moving the 5 to the other side, x equals negative 5. So x cannot equal negative 5 because this will cause the whole thing to become 0. So my domain is going to be from negative infinity up to 5, union with from 5 up to positive infinity. Now let's try and find the y-intercept. So setting x to 0, this is going to be y equal 1 over 0 plus 5. So y equals 1 over 5. So my y-intercept is going to be at the point 0 and 1 over 5. My x-intercept is going to be when I set my y to 0. So 0 equals 1 over x plus 5. And over here, I can multiply both sides by x plus 5, and I will have 0 equals 1, which is wrong. So this is undefined. So I do not have an x-intercept. There is no x-intercept here. Let's check our answer. First, the domain is everything except negative 5. So let's check that. As you can see, that the domain is literally everything except negative 5. If we plot x equals negative 5, we will see this vertical line. Our graph is going to approach it, to keep on approaching it, keep on getting super close to it, but it will never touch it. My x will never be negative 5 on my actual function, and it's the same in the other direction. Okay, so my domain is correct. My y-intercept is 0 and 1 over 5. So let's see, where is my y-intercept? So my graph hits the y-axis at 0.2. So this is 1 over 5. So this is correct. And I said that I do not have any x-intercepts. As we can see, that the graph is also going to keep approaching the x-axis, however, it will never touch it. And by the way, this, we call it a horizontal asymptote, and I'm going to teach you in later videos how to calculate that. So let's take another example. Let's say our example is we need to find the domain, x-intercept and y-intercept of the function y equals 1 over x squared minus 6x. Okay, so first of all, this is a rational function. My domain is going to be restricted by, I do not want the denominator to equal 0. So x squared minus 6x equals 0. Let's solve that. Let me take x as common. So it's going to be x squared divide x, that is x, minus 6x divide x, that is minus 6, equals 0. So I will have two solutions when this is equal 0 and when this is equal to 0. So my two solutions are x equals 0 and x equals, or x minus 6 equals 0. That makes x equals positive 6. So my domain is everything except 0 and 6. So to write that in domain notation is going to be x is everything from negative infinity up to 0, and then from 0 up to 6, and then from 6 up to infinity. So this is my answer for my domain. Let's try now to get the y-intercept by setting x equals 0. So 1 over 0 minus 0 is 0. So I will have a 1 over 0 equal y. This is undefined, so I do not have a y-intercept. Let's try to get the x-intercept intercept by saying that y is going to equal 0 now. So 0 equals 1 over x squared minus 6x. So again, 1 is going to equal 0, which is wrong. So again, I will not have any x-intercept. So let's check our answer. So we said that our domain is everything except 0 and 6. So let's check that. So if we plot the function, we will see that our domain is literally everything from negative infinity up to 0. So this x over here, 0, it's going to keep approaching 0. However, it will not touch it ever. And then it's going to be from 0 up to 6. And it will not be touching 6 again. And then from 6 up to infinity. And this is correct. And we said that we will not have an x-intercept nor a y-intercept. And as I can see, the graph is not going to touch the y-axis ever or the x-axis ever. So we are correct. So let's take another example. Let's say we have y equals square root of x minus 4. So this is a square root function. Let's start by getting the domain. My domain is restricted by what's inside the square root can never be negative value. So x minus 4 should be greater than or equal to 0. That makes my domain x greater than or equal to 4. So to write this, I will have a square bracket because I'm including 4 now, because x is greater than or equal to 4, up to infinity and close bracket. Okay? So this is my domain. My y-intercept is going to be when I set my x equals 0. So y equals square root of 0 minus 4, so it's negative 4. Square root of a negative number is undefined, so I do not have any y-intercept, none. For the x-intercept, I will set y equals 0, equals square root of x minus 4. Solve for x, so square root, this cancels, square root of, squared. I'm squaring everything, so squaring both sides. These cancel, 0 squared is 0, equals x minus 4. So x is going to equal 4. This is going to be my x-intercept. So my domain, I said that x is going to equal 4 or any value greater than 4. I do not have a y-intercept and my x-intercept is 4. Let's check that. So for my domain, x is 4 and after and greater. I do not have any y-intercept. My graph is not going to touch the y-axis. And my x-intercept, the graph touches the x-axis at the point 4. So I am correct. So as you can see, as we're moving, we're gathering information, okay, that will help us draw the graph. And when we do all 6 steps, we're going to have enough information to graph any single function. So let's take the next example. Our function is now y equals x cubed minus 2x squared over x squared plus 3x minus 18. Okay, this is a rational function. So as always, let's start by the domain, saying that the denominator cannot equal 0. So let's solve the denominator equals 0 and see what is it going to give us. So over here, I can solve by factorization. I need 2 factors of 18 that will subtract to 3. These are 6 and 3. I will have my brackets x, I'll have a 6 and a 3. The greater value takes the middle sign, so this is going to be plus, this is minus, equals 0. So I have x plus 6 equals 0, which is going to give me x equals minus 6. I'll have x minus 3 equals 0, which is going to give me x equals positive 3. So my x is going to be the x, negative 6 and 3 are going to cause this to be 0 and are going to cause the denominator to be 0. So my domain is going to be everything except these 2 values. So to write that, I'm going to have from negative infinity up to negative 6, union with from negative 6 up to 3, union with from 3 up to positive infinity. And this is my answer for the domain. Okay, let's find our y-intercept by setting x equal 0. So y is going to equal 0 cubed minus 2 times 0 squared over 0 squared plus 3 times 0 minus 18. So this whole numerator is 0 over 0 plus 0 minus 18, so minus 18. 0 over anything is basically 0, so my y-intercept is 0. So I'm going to have the y-intercept as 0 and 0. And since x is 0 as well, I know that 0, 0 is going to be also an x-intercept. However, let's try to see if we will find another x-intercept. So x-intercept, to find that, we will need to set y as 0. So 0 equals x cubed minus 2x squared over x squared plus 3x minus 18. So we can multiply both sides by x squared plus 3x minus 18. So it's going to become 0 equals x cubed minus 2x squared. So let's solve that. So what I can do is I can take x squared common. This is going to leave behind x cubed divided x squared is going to be x. Minus 2x squared divided x squared is minus 2 equals 0. So this gives me two answers. X squared equals 0, which basically I can take square root of both sides. That will give me x equals 0 as my first answer. And x minus 2 equals 0, which is going to give me x equals 2 as my second answer. So I will have two x-intercepts at x equals 0 and at x equal 2. So my domain is everything except negative 6 and 3. Let's check that. So my domain is going to be literally everything except x equals negative 6 and x equals 3. And as you can see, when I plot those two vertical lines, I will see that my graph will keep approaching those lines, but it will never touch them. That means that my solution is correct. And I calculated my y-intercept at 0, 0, and the graph actually touches the origin point, which is correct, as we can see from here. My first x-intercept was 0, and my second x-intercept was at x of 2, and I can see that this is right as well. So, let's continue. Let's take this next example. Let's say we have y equals x squared minus 2x minus 24. This is a polynomial, so domain is all real numbers. Y-intercept is going to be setting x equals 0. So y is going to equal, this is 0, this is 0. So y is going to equal minus 24. And x-intercept, I'm going to set y equals 0. So 0 equals x squared minus 2x minus 24. Solving this, I can factorize. I will need two factors that subtract to 2. Factors of 24 are 6 and 4. So this is going to be x, 6, and 4. Greater value will take the middle sign, so minus, and this is going to be plus. So my x is going to equal 6, and x equals minus 4. These are my two x-intercepts. Let's check that. So over here, our y-intercept is basically minus 24, as we calculated it. Our two x-intercepts are minus 4 and 6, so that means we are correct. So let's take another example. Y equals 2x minus 3 over 3x plus 5. So first of all, this is a rational function, so my domain is going to be restricted by the denominator not equaling 0. So 3x plus 5 equals 0. So 3x equals minus 5. So x equals minus 5 over 3. And when x is minus 5 over 3, the denominator is 0. So my domain is x not equal minus 5 over 3, which is going to be from negative infinity up to negative 5 over 3, union with from negative 5 over 3 up to infinity. This is my domain over here. So y-intercept is going to be when x equals 0. So setting this equal to 0, this is going to be 0. This is going to be 0. I will have a minus 3 over 5, so y equals minus 3 over 5. So y-intercept is at the point 0, minus 3 over 5. X-intercept is when setting y equals 0. So basically setting the numerator to 0. So 2x minus 3 equals 0. So 2x equals 3. So x equals 3 over 2. So my x-intercept is going to be 3 over 2 and 0. So let's check that. Our domain is everything except minus 5 over 3. So if we plot it, we will have, if we graph minus 5 over 3, we are going to have a vertical asymptote basically, or the graph is never going to touch this line. This shows that we are correct. Our y-intercept, we calculated it as negative 3 over 5, which is negative 0.6. That's correct. Our x-intercept was 3 over 2, which is 1.5, and that is correct as well. So let's take one more example, and then I'm going to show you something that's going to help us a lot in the next video. So let's say y equals 3x squared over 2x squared minus 5x minus 3. So again, this is a rational function. My domain is going to be when the denominator equals 0. So 2x squared minus 5x minus 3 equals 0. So I can solve this using the quadratic formula, which is going to be minus b, so minus negative 5, plus or minus square root of b squared, so minus 5 squared, minus 4 times a, which is 2, times c, which is negative 3, over 2 times a. So I'll have two values, one when this is plus, one when this is minus. So if I put this on the calculator, I will have my first x as 3 and my second x as negative half. So basically these two values are going to cause this expression to become 0, making the denominator 0, making the whole function undefined. So my domain is going to be everything except these two values. So writing it down, it's going to be from negative infinity up to negative half, union with from negative half up to 3. Try to solve this on your own and then watch along. Union with 3 up to infinity. This is my domain. My y-intercept is when I set my x equal to 0. So if x equal to 0, this is going to be 3 times 0 squared over 2 times 0 squared minus 5 times 0 minus 3. So literally everything here is 0, and we will have a 0 over minus 3, which is equal to 0. So my y-intercept is going to be at point 0 and 0. My x-intercept is going to be when setting this whole y equal to 0. So basically setting the numerator to 0. So 3x squared equals 0, making x equals 0 as well. So my x-intercept is also 0 and 0. So let's check our answer. Our domain is everything except 3 and negative half. So we'd expect a vertical asymptote at those locations. So x equals 3 will have an asymptote, and x equals negative half, we will have another asymptote, as you can see from the graph. And we calculated both intercepts at 0 and 0. So let me show you something, okay, that will help us a lot in the next video. So let's say we have this interesting function, y equals x plus 2 over 3x squared plus 6x. So again, my domain is going to be when 3x squared plus 6x is not equal to 0. So let's take 3x out. This is going to be 3x squared divided 3x is basically x, plus 6x divided 3x is basically 2 equals 0. So over here I will have when 3x equals 0, this is going to give me x as 0, and when x plus 2 equals 0, so x equals minus 2. So my domain is from negative infinity up to negative 2, union with negative 2 up to 0, union with 0 up to infinity. Okay, now my y-intercept is going to be when x equals 0. So this is 0, this is 0, this is 0. So it's going to be 2 over 0, which is undefined. So I will not have any y-intercept. And the interesting part is here. My x-intercept, the way we solved is basically, let's just remove this. The way we solved, this was none, was setting y equals 0. Let's do that. So 0 equals x plus 2 over, instead of writing 3x squared plus 6x, I'm going to write it in this form, and I'm going to show you why later. So 3x times x plus 2 equals 0. I can see here that there is a repeated factor that could be cancelled from the numerator and the denominator. I will show you why this is important. So based on what we have been doing, what you will tell me is, okay, I will set the numerator equals to 0 to get my x-intercept. So my x-intercept will be at x equals minus 2. How is that possible? X, my domain, is basically everything except minus 2. Okay, and my x-intercept is minus 2. How is that possible? If we plot this graph, we will see that we actually do not have an x-intercept at minus 2. We can see that when x is minus 2, we do not cross the x-axis. Why is that? When I cancelled this factor with this factor, this now created something that's called a hole for me. This is a hole. It's basically a single point that is not defined by the graph. So as I can see, all of these are points on the graph until I come to -2. I will find that it is undefined. I actually do not have a point over there. That's why it's a white circle. So it's undefined. This is called a hole. And holes happen when, after factorizing the numerator and the denominator, when you cancel factors from the numerator and the denominator together. So if this was x plus 2 squared over 3x times x plus 2, I will cancel one of those x plus 2's over here, and since the numerator is having a higher power than the denominator, again this is going to be a hole. Okay, in either way, my graph is not going to be defined at x equals minus 2, because this whole thing is going to be a 0. The thing is, we need to determine, is the kind of undefining, is it going to be an asymptote? Is the graph going to be something like this? Is it going to be an asymptote, let's say, like over here, let's say this, so this is a vertical asymptote, or is the graph going to be, so this is an asymptote type, or is the graph going to be a hole? So it's going to have something, and then at my x that is -2 or 2 or whatever, I'm going to have a hole, and then I'm going to continue my graph. So what determines, is it this kind, or both are undefined? Both, there are no value at this x over here. There are no value. However, is it an asymptote or is it a hole? What determines is the degree over here. If the numerator has a higher degree, then it's a hole. If the denominator has a higher degree, it's an asymptote. If they both have the same degree, it's also a hole. So whenever I have a repeated factor in the numerator and the denominator, if they are both the same degree, I will have a hole at that x that's going to cause it to become 0. If the numerator is a greater degree, I will also have a hole. If the denominator is a greater degree, so if this was, let's say this was x plus 2 and this was x plus 2 squared, then this is going to cancel with this, and I will still have an x plus 2 over here. Now it will still be unidentified at x equals -2. However, it will be the asymptote type. And this is going to be our next video, and I'm going to show you how to combine all these things plus holes, and to check if you have any holes, because this will help you in drawing and sketching your graph. Anyways, thank you so much for watching. Hope this video was helpful. Please stay tuned for the other videos. They're going to be super helpful for you. Don't forget to like, comment, and subscribe. Thank you for watching, and have a nice day.